Hello everyone, so for this next video I'm going to go ahead and cover 3.2 differentiating inverse functions. So I don't know how much you guys actually remember about inverse functions, but just a couple of things in the beginning I just want to remind you guys is that a function's inverse is found by swapping the x and the y values. And I don't know if you remember, but like back in algebra 2, we would get, like, for example, if we had y or f of x is equal to 2x plus 5, what we would do is we would just swap the x and the y. And then we would just solve for y and say that is the inverse function. So I don't want you guys to get like the f of -1 of x compared to x to the -1 confused. This one right here, this is a reciprocal. Reciprocal, I don't know how to spell, whatever. So you know that if you have x to the -1 power, you know, we've done this with power rule before, and it's just like 1 over x, right? But if you have the -1 power attached to your function notation, that means the inverse of f. Okay, so please don't get those two things confused, all right? Because you're going to treat each of those derivatives a little bit differently, all right? So the other ways that you can possibly see them saying inverse on the AP exam is they would just flat out say g of x is the inverse of f of x. Sometimes they'll use the notation g of x is equal to f -1 power of x, right? Which is the inverse of x. Sometimes they'll even go ahead and say that f of g of x is equal to x and g of f of x is equal to x. And this is actually something that has been proven before in algebra. I don't want to spend the time to prove this, but you should just know that. So sometimes they'll just kind of embed that in the question, and then that should, when you see them say that, you should immediately think, oh, that just means that they're both the inverse of each other. All right. So I guess before we go any further, I wanted to include this inside of the notes, just because I feel like whenever we're used to reading tables, we kind of have to think a little bit backwards whenever we're asking for the inverse of, or to evaluate the inverse of any sort of function. So, for example, if I want to know what is f of g inverse of 0, well, again, if I said, okay, well, what is like g of 0, for example, like when I'm looking at a table, you would look for the x value at 0, find g of 0, and then the one that's below that column is the answer. Whenever you're looking at g inverse, though, you got to remember you're swapping the x and the y. So you're not going to be starting off at the x column, you're looking at the y column now. So you're going to say, okay, well, g inverse of 0, I got to look at my y column where y is 0, right? And then that the one that corresponds to the x column is my answer for that. So g inverse of 0 with a y of 0, my x is 1. So my answer for that is going to be 1, right? So this is 1. So now that we substituted this for 1, we're going to say, okay, well, f of 1 is... This is where we follow the normal convention where x equals 0 or where x equals 1. So at x equals 1, f of x is -1. All right. If we look at part B, it says f inverse of f of -1. Well, this is just a kind of a theorem from here, right? If we have f of g of x of x, or f inverse of f, it's just going to be the x value. But I guess to just kind of prove it to you is like, if I look at f of at x equals -1, at x equals -1, f is f of x is 4, right? Well, f inverse of 4, well, this time I got to look at my column for y's, and then that corresponds to my x value, so that's just back to -1. So if you have the f inverse or the f of the inverse of an x value, it's just going to be that x value. Then for this one, again, g inverse of -1. So if it's inverse, I got to look at my y values at -1 and see what x that corresponds to. So a y value of -1 under g is 3. So f inverse of 3 is what I'm trying to find. Then I got to say, okay, well, most people would make a mistake here and say, okay, well, I'm looking at my x. But again, if it's f inverse of 3, I got to look for my y value where it's equal to 3. And since I don't have a y value of 3 under f, I'm just going to say this is undefined. All right, one last one. F inverse of 4, well, I got to see where's my y value, 4. So here it's 4, so then the corresponding x value is -1. So it's going to be g inverse of, this is -1. And then I got to see, okay, well, g inverse of -1, I got to see, okay, well, where's my y value, -1, and then the corresponding x value is 3. So then this answer is just equal to 3. All right, I just wanted to do those exercises because this is something that we're going to do often with the problems coming up. So now let's actually talk about the derivative. The derivative, it's a formula, and it's even a formula that even me, as much as I've done calculus, it's a formula that I always forget because I don't practice this enough. But for some reason on the AP exam, they really wanted to emphasize this formula, so I think it's fair game that it's going to be on there. So the derivative of an inverse function of x is equal to 1 divided by f of the inverse function of x. Okay? This is just something you've got to memorize. Memorize it. I recommend that every time you do a problem, you just write it out so that you don't forget it. Every time, when you practice it enough, it should hopefully stay in your brain. So it says over here at the table below gives values of the differentiable function f, g, and f prime at selected values of x. Let g of x equal f inverse of x. So for part A, they're saying, what is the value of g prime of 1? So if they want to know g prime of 1, well, I know g of x is equal to the inverse of f of x. So if I want to find g prime of x, they're essentially asking me, what is the derivative of f inverse of 1? Okay, because we know that g is f inverse. So I'm going to go ahead and rewrite this using my formula. This is the same thing as 1 over f prime of f inverse of 1. All right, so as long as you can look at a table and determine what is f inverse of 1, you'll be good to go. So f inverse of 1, I need to know what my y value is at 1. So my y value at 1 gives me an x value of 2. So this is 1 over f prime of 2. Okay, so then f prime of 2, okay, well, this is an f prime at an x value of 2. So at x equals 2, my f prime of 2 is -2. So this is 1 over -2. All right. I know that, I hope this isn't a little weird for you guys, because I know our standard convention is to look at the column of x's first and see what values correspond to that. And we have to work a little bit backwards, but with enough practice, you should be okay with this. Now this one is saying write an equation for the line tangent to f inverse of to f inverse at x equals 1. Well, good thing we already found the slope. So now we got to say, okay, well, f inverse of 1. Let's see. So f inverse of 1, right? Well, what is the y value that corresponds to? Well, f inverse of 1, we already said that that's 2. So that means this is going to almost be like our x coordinate and y coordinate of the inverse function. So we're going to go ahead and create our linear equation. Y minus 2 is equal to -1/2 times x minus 1. All right. So let's move on to the next page. All right. So I'll go ahead and do this first one, and then you guys should be able to do this one on your own. So it says, suppose that f of x is equal to 3x plus 2 and f prime of -2 is equal to 3. What is the value of f inverse of -4 derived? So I'm going to go ahead and say, okay, well, what's the derivative of f inverse of -4, right? And I'm doing this just to remember what this formula is. It's going to be 1 over f prime of f inverse of -4. All right. So now I got to say, okay, well, what is f inverse of -4? Oh, shoot. All right, sorry. So, okay, I got to say, well, my y value of -4, well, let's see. -4 is the y value for f of x, right? If so, in this case, -4 is the x value for the inverse, then it has to be the y value for the original function of f, right? So we're going to go ahead and solve for it. So if I'm going to go ahead and set -4 as my y value for my original function. So it's going to be -4 is equal to 3x plus 2. And then I'll solve for x. I'm going to subtract 2 from both sides, divide by 3. So x is equal to -2. So again, looking at from the perspective of my original function, my f of -2 was equal to -4. What was originally the x in my or the x value in my original function and my y value in the original function, I'm going to swap them, and that's going to tell me that the f inverse of -4 is actually equal to -2. Again, you have to get yourselves in the mindset that inverse is swapping the x and the y of the original. So that means that this answer is actually -2. So 1 over f prime of -2. And it already told us in the problem what f prime of -2 is, so that's equal to 1 over 3. All right, so there's one problem. I want you guys to try to do the next problem on your own. All right, so let's look at this next problem. It says, let g be a differentiable function such that g of 12 is equal to 4, g of 3 is equal to 6, g prime of 12 is equal to -5, and g prime of 3 is equal to -2. The function h is differentiable, and h of x is equal to the inverse of g of x for all x. What is the value of h prime of x? Or h prime of 6, sorry. So over here, if we want to take the derivative of h at 6, well, that's pretty much, well, they already define h as being the inverse of g. So really what we're trying to do is figure out the derivative with respect to x of g inverse of 6. And again, it's just a matter of remembering to set up your formula. So you're going to have 1 over g prime of g inverse of 6. And so, you know, they gave us a lot of different things here to potentially work with, but some of this we're not even going to look at. So if I want to know what is the inverse of, or the g inverse of 6, well, I got to see, okay, well, first of all, where do I even have a 6? I have this right there. And again, you have to recognize that the inverse of g, I gotta swap my x and my y. So if I have, so if I know that g of 3 is equal to 6, well, if I swapped my x and my y, then I know that g inverse of 6, well, that's just equal to 3. So I can go ahead and substitute 3 into there. And so a lot of this other stuff I'm not even using. So I'm going to go ahead and set this equal to 1 over g prime. G inverse of 6 was 3. And now I just got to grab the one that corresponds to this. So g prime of 3 we know is -2. And that's our final answer for that. All right. So that one was pretty straightforward. Again, they threw a bunch of other things in there just to kind of throw you off and see if they can get you there. But it wasn't even necessary. So for this one, it says if f of x is equal to 3x cubed plus 1, and g is the inverse function of f, what is the value of g prime of 25? All right, so I want to know the derivative of g prime of 25. Well, I know that g is inverse of f, so I'm just going to go ahead and rewrite that as f inverse of 25. This is what I'm trying to find the derivative of. And I'm going to just go ahead and set up my, my equation like I have been. 1 over f prime of f inverse of 25. I don't know why sometimes I use brackets and other times I use parentheses, but whatever, it's the same thing. So now I got to figure out, okay, well, what is f inverse of 25? Okay, so this is probably the most involved problem that I have, or that you'll probably see for these types of problems. So now we just got to sit here and analyze it, because now we're going to have to do a little bit more algebra to solve this one. So f prime of 25. Well, 25, right? If 25 is the x value for f inverse, then that means it's the y value. So I'm just going to write that here. 25 is the y value for f of x, right? So what I'm going to do, I'm going to plug 25 into f of x, right, is equal to 3x cubed plus 1. And then I'm going to solve for x and see what x value does that correspond to. So I subtract 1 from both sides. 24 is equal to 3x cubed. Divide by 3. 8 is equal to x cubed. So then x is equal to 2. right? So essentially, x is 2 and y is 25 for the original function, right? So for f of the original 2, that's equal to 25. So then that means that f inverse of 25 is equal to 2, right? So now I'm going to go ahead and plug that into this. So I have this is equal to 1 over f prime of 2. Right now I got to figure out what is f prime of 2. Well, I know that f prime of x, now I got to go ahead and take the derivative like we have been in all of chapter 2. I'm going to take the derivative of this, and that's equal to 9x squared plus 1. No, that's going to be 0. Sorry. And so then f prime of 2 is equal to 9 times 2 squared. So 9 times 4 is 36. And that is my final answer. All right. Just a tad bit more involved. So, because, we actually had to take the derivative of x, but it's pretty similar to like this one and even this one that you'll see in the solutions for later. So I'm going to go ahead and just leave this one to you guys. It's just more of the same, setting up your equation or your formula, and reading the graph and working backwards and knowing which numbers to work with. So I always post the solutions to the notes or the filled in version of the notes and inside of Canvas. So just go ahead and check those out, and I'll just end the video right there with that problem. All right. So I hope this was helpful. And again, look out for the problem set. And we will start 3.3 the next day. See you.